In this problem, we have a two-way frequency table again. In this case, it's some data about patients who either took an old medication or a new medication for a certain condition, and then whether they showed improvement or no improvement. And what we're going to do here is calculate some probabilities and then use that to make a decision or an inference about whether the old medication or the new medication makes a difference. So let's take a look at what they're asking us over here. It says, find the probability that the patient showed improvement. So improvement is this category right here, and we have 51 on the old medication, 54 on the new medication. I would add those together, that's 105, and put that over the total in the whole thing. It's 150 patients. So 105 divided by 150, let me grab my calculator. So that is 0.7. So our answer there, the probability of improvement is 0.7. So that's pretty good. 70% chance you're going to improve, whether you take the old medication or the new medication. I guess things don't look so bad for these patients. B says, find the probability that the patient showed improvement given that he took the new medication. When they say given, that's what this line means, the new medication, we're only going to look at this set of numbers now. So our total is going to be different. We have to add these two together to get our new total. 21 plus 54 is 75, so that's what we'll put on the bottom of our fraction. And we're looking for improvement given new medication. That would be 54. And let's take 54 and divide it by 75, and that is 0.72. So what I'm seeing here is that if you've got a 0.7 chance of improving no matter what medication you're taking, old or new, and only an improvement of 0.72 when you're taking the new medication, doesn't look like there's a whole lot of difference. So if the new medication costs a lot of money, it doesn't seem to make sense to do that because it's almost the same level of improvement, whether you're taking old or new. So let's take that information and see if we can answer the question down here. C says, is there evidence that a patient who takes the new medication is more likely to show improvement than a randomly chosen patient from the group? So, well, there's this tiny little difference. I would say probably you'd need to show a bigger difference than that if you were going to be sure that taking the new medication was worth it. So I'm going to go for one of these no's. Let's see, no, because the probability found in Part B was much greater. Well, that doesn't make sense. If it was much greater, that would be evidence that it does make a difference. All right, here's another no. No, because the probability found in Part A is much greater. Well, it's not much greater. Or here's a no. No, because the probability found in Part B is about the same as the probability found in Part A. And I think that's what we have going on here. We have about the same. If the probability of A was much greater, that would definitely be a no as well. But that's not our case here. We've got them about the same. So that is how to compute some conditional probability and use it to make a decision.